The constant rule states that the derivative of any constant is always 0, because constants don't change. When you have a function like f of x equals 5, no matter what value x takes, the output is always 5. Since there's no change, the rate of change is 0. The formula is the derivative with respect to x of c equals 0. For example, if f of x equals 12, then f prime of x equals 0. Similarly, if f of x equals negative pi, then f prime of x equals 0. The power rule is used when x is raised to any power, whether it's a positive integer, negative integer, or fraction. To apply it, bring the exponent down as a multiplier, then subtract 1 from the original exponent. The formula is the derivative with respect to x of x to the power n equals n times x to the power of n minus 1. For example, if f of x equals x to the power 5, bring down the 5 and subtract 1 from the exponent. So f prime of x equals 5x to the power 4. If f of x equals x to the power negative 3, bring down negative 3 and subtract 1. So f prime of x equals negative 3x to the power negative 4. This rule applies when a constant is multiplied by a function. The constant stays unchanged while you differentiate the function. The formula is the derivative with respect to x of c times f of x equals c times f prime of x. For example, if f of x equals 7x cubed, the constant 7 stays in front, while x cubed becomes 3x squared, giving f prime of x equals 21x squared. If f of x equals negative 4 sine of x, the negative 4 remains while sine of x becomes cosine of x, giving f prime of x equals negative 4 cosine of x. If f of x equals 2/3 times x to the power 4, we get f prime of x equals 2/3 times 4x cubed, which is 8/3 x cubed. When functions are added or subtracted, differentiate each term independently and keep the same signs. The formula is the derivative with respect to x of f of x plus or minus g of x equals f prime of x plus or minus g prime of x. For example, if f of x equals x cubed plus 5x squared minus 2x plus 7, differentiate each term. X cubed becomes 3x squared, 5x squared becomes 10x, minus 2x becomes minus 2, and 7 becomes 0. So f prime of x equals 3x squared plus 10x minus 2. The product rule is used when two functions are multiplied. Take the derivative of the first times the second unchanged, plus the first unchanged times the derivative of the second. The formula is the derivative with respect to x of u times v equals u prime v plus u v prime. For example, if f of x equals x squared times sine of x, let u equal x squared and v equal sine of x. Then u prime equals 2x and v prime equals cosine of x. So f prime of x equals 2x sine of x plus x squared cosine of x. When one function is divided by another, use the formula. The derivative with respect to x of u over v equals u prime v minus uv prime divided by v squared. For example, if f of x equals x cubed over cosine of x, let u equal x cubed and v equal cosine of x. Then u prime equals 3x squared and v prime equals negative sine of x. So f prime of x equals 3x squared cosine of x plus x cubed sine of x divided by cosine squared of x. Quotient rule is used for composite functions where one function is inside another. First, differentiate the outer function, leaving the inner function unchanged. Then multiply by the derivative of the inner function. The formula is d by dx of f of g of x equals f prime of g of x multiplied by g prime of x. For example, if f of x equals 3x squared plus 5 raised to the power of 4, the outer function is u to the power of 4, and inner is 3x squared plus 5. Differentiate outer, 4u cubed, keep inner, 4 multiplied up by 3x squared, plus 5 raised, to the power of 3, multiply by inner's derivative, 4 multiplied by 3x squared, plus 5 raised to the power of 3, multiplied by 6x equals 24x, multiplied by 3x squared plus 5 raised to the power of 3. For f of x equals sine of x squared, we get f prime of x equals cosine of x squared, multiplied by 2x, This is fundamental for complex nested functions. Exponential function rules. For exponentials with base e, the derivative of e raised to the power x is simply e raised to the power x itself. The formulas are d by dx of e raised to the power x equals e raised to the power x, and d by dx of a raised to the power x equals a raised to the power x multiplied by natural log of a. For example, if f of x equals e raised to the power 5x, the derivative is e raised to the power 5x multiplied by 5, which equals 5e raised to the power 5x. Logarithmic function rules. For natural logarithm, the derivative is 1 over x. The formulas are trigonometric function rules. Each trigonometric function has a specific derivative pattern. Sine becomes cosine. Cosine becomes negative sine. Tangent becomes secant squared. Cotangent becomes negative. Cosecant squared. Secant becomes secant multiplied by tangent, and cosecant becomes negative cosecant multiplied by cotangent. For example, if f of x equals 3 sine x plus 2 cosine x, combine the rules. F prime of x equals 3 cosine x plus 2, multiplied by negative sine x, which equals 3 cosine x minus 2 sine x. Remember to use the chain rule for composite trigonometric functions. This is essential in wave mechanics and oscillation. Inverse trigonometric function rules. These functions return angles and have specific derivative formulas. For arcsine of x and arccosine of x, use 1 divided by square root of 1 minus x squared, with positive for arcsine and negative for arccosine. For arctangent of x and arccotangent of x, use 1 divided by 1 plus x squared, with positive for arctangent and negative for arccotangent. Hyperbolic function rules. Hyperbolic functions behave similarly to trigonometric functions, but with slightly different patterns. Hyperbolic sine becomes hyperbolic cosine. Hyperbolic cosine becomes hyperbolic sine, positive, not negative. Hyperbolic tangent becomes hyperbolic secant squared, and so on. Inverse hyperbolic function rules. These have formulas involving square roots, similar to inverse trigonometric functions, but with plus or minus signs reversed in the radical. For inverse hyperbolic sine, the derivative is 1 divided by square root of x squared plus 1. For inverse hyperbolic cosine, where x is greater than 1, it is 1 divided by square root of x squared minus 1. For inverse hyperbolic tangent, where absolute value of x is less than 1, it is 1 divided by 1 minus x squared.